Ladies and gentlemen, welcome to the design presentation of the Delft Hyperloop team. Welcome friends, welcome family, but also people who are watching our live stream, welcome. And especially I would like to welcome our partners who would really make this project also a success. But before I will start with my presentation, I would like to take you back in time. I would like to take you till 1949. And at this time, it was already possible to get by train from Amsterdam to Enschede. And at that time, this took you 2 hours and 13 minutes. And currently, we live in 2016. And how much time do you think it will take now? It's 2 hours and 40 minutes. Can you believe that, guys? In over more than 60 years, not a single innovation on transportation has been made on this project. And that means it's time for innovation. My name is Tim, and together with Mars, we will convince you that the Hyperloop is the future of the transportation. But before that, I would like to point on the current transportation problems. And because we have a Dutch audience, I have some Dutch examples. Well, first of all, here you see a guy, and he is cycling against the wind. And as you can see from his face, it costs him a lot of energy. But it's not only this guy. Every single current transportation system is pushing away the air particles, hitting it. And because you need to push away the air particles, it costs you a lot of energy. Most of the energy of the current transportation goes up to the air resistance. So that's problem number one. Problem number two, money. We all love it, and we hate to spend it. And current transportation is quite expensive. Because it uses a lot of energy, and energy costs money, it is expensive. And the current transportation systems requires also a very severe infrastructure, making it expensive. And then, the third problem. You see this? It's not really reliable. Even a single leaf on the track can lay down the complete infrastructure. And that's not what we want. So how would the ideal transportation system look like? It would be more efficient, it would have lower cost, and it would have a higher reliability. But how can we achieve this? With the Hyperloop. The Hyperloop is sort of a train in a tube, and in that tube, there is almost no air. And because there's almost no air, there is very little air resistance, making it a very efficient system. And that train in the tube, it's floating in the tube. And therefore, there is no mechanical contact, making it a very maintenance-free system. And therefore, it's also very cheap with the running costs. Secondly, what's very nice, the train is propelled by linear electrical motors. And because there is so less air resistance, you can just float to the end station, regenerate back the energy you've used, making it a very efficient system. And the energy you use for acceleration is gained by solar panels on top of the tube. And if we take a look to the travel speeds, the Hyperloop can be by far the fastest transportation system if you compare it to the car, the train, and the airplane. But now comes the interesting fact. If you take a look to the energy consumption, Hyperloop uses by far the least amount of energy. And that's exactly what you want. You want the most speed with the least energy. And actually those numbers, they don't say quite much to me. So therefore I made a comparison. If you would like to go from the Netherlands till the south of France with the Hyperloop, it's around 1,000 kilometers, and you go there with 1,000 kilometers an hour, it will cost you the same amount of energy as 3 liters of fat. Well, that's not much, right? So is this the solution for every transportation problem? Well, actually, it's more like an addition. If you take a look to the train is a quite convenient transportation system. You just go to the station, you get in, have your trip. The only problem is, it's not very fast. And if you take a look to the airplane, the airplane is fast, but when you go there, you have a lot of boarding time, and when you are actually in the air, it also takes you a lot of time. And what a Hyperloop does, it combines the best of both worlds. So therefore, we also say that a Hyperloop is as fast as a plane, but as convenient as a train. At which distances is the Hyperloop good? The Hyperloop is an efficient transportation system from 100 till 1,000 kilometers. And you could reach all this area with a Hyperloop from the Netherlands. After 1,000 kilometers, the airplane, it makes more sense because you don't need the infrastructure. But before that distance, Hyperloop is efficient. And you could just imagine, with one Hyperloop you could travel there, but if you have more Hyperloop stations, you can organize a whole hub of Hyperloop systems. Back to this. You can travel with a Hyperloop to the south of France. And do you all remember Black Saturday? Times like this, they will be over. Well, is this idea all new? Actually, it is not. All from the years of 1900s, people were thinking about a tube transportation system, but it never really came off the ground. Until this guy, Elon Musk, the CEO of Tesla Motors and SpaceX, he encountered the Hyperloop. And what he did, he has written a conceptual paper of the Hyperloop with respect to a transportation system they would use in California. And that transportation system was very expensive and not very fast. And he said, this could be faster and way more efficient for a lot lower price. And during the time, this was in 2014, the founders of the Delft Hyperloop team were part of the Formula Student team. And this team, they built electrical race cars for a competition. And because we were so focused on competition, we immediately said, how nice would it be if there would be a Hyperloop competition? And 1.5 years later, this became reality. SpaceX organized the Hyperloop competition. And then, 1 week later, Delft Hyperloop was formed. So what we did, we went back to the Dream Hall. This is the building where all the big teams of the TU Delft house themselves, like the NUA, and also there. We get an office, make clear who we are and what we do. We will start dreaming and thinking about how we could win this competition. We were getting some plants to make the air nice and have a little oxygen for our brains. And quite soon, we end up with an office where we could recruit our team and start thinking about a top-level concept. And we did that quite well. We recruited on different Facebook groups, and we got almost 200 applicants. So we also had to make a selection to filter out the most motivated and passionate team members. And at the end, we ended up with this team to start in September, hopefully winning the Hyperloop competition. And if you want to build an A product, you need an A team. And this is our A team. Well, but how do you organize such a big team? Therefore, we have divided the team into 3 technical departments. And each department has a head. The head of the structure department is Marinus van der Meijs. He's a very serious guy, but he can also be quite fun, you can see here. Oh. Then we have the head of powertrain. This is Kian. And the head of controls, this is Sasha. And to keep each department integrated together with a part, we have the technical chief, and that is Mars Geuze. And for all the non-technical stuff, we have the operations department. They focus on the partnerships, the public relations, the financial part of the team, but also the motivational part. And I'm the head of that department. So with that team, we do not only work hard, we also have fun. Therefore, almost every evening, we eat together just to get in touch with each other more. We do paintballing to really build up a strong bond between our team. But there also needs to be worked. And that we do here. And during this time, we were still busy with our conceptual design. And it was around October. And our conceptual design, it looked like this. Looked quite nice. And this immediately went all over the Netherlands quite quick. Therefore, we went on Radio 1, RTL, different magazines, RTL News, and even nu.nl, because we thought about the conceptual design that was good enough to pass till the next round of the competition. But that's not the only thing we have encountered. From September on, we were already contacting different partners to help us making realize our dream to win the competition. And I'm happy to say that we have done that quite well. We have an enormous list of partners, and I would really like to thank every partner here, and I'm very proud to show you our big list of partners. Give them an applause. And one of those partners is Martin Schuurman. Martin Schuurman is the CEO of MKB Brandstof, but also the chairman of the Change Club. May I welcome you on stage, Martin. Martin really boosts entrepreneurship, and therefore, I would like him to tell something about his connection with the Hyperloop team. Martin, there you go.
Good evening. When I was young, it seemed that life was so wonderful, a miracle. It was beautiful and magical. But then I went away to be taught in Delft how to be sensible, logical, responsible, and practical. And they showed me a world where I could be so dependable, clinical, responsible, and practical. And they showed me a world where I could be so dependable, clinical, intellectual, and cynical. It was a lonely life. My fellow students seemed to live in a different world, a world filled with joy and beauty of mathematics and electronics. It made me feel odd. I did not attend classes. No need to talk about the fact that 1 + 1 = 2. My life revolved around friendships, my student fraternity, and some early entrepreneurship. Nevertheless, Delft taught me a lot, and for sure prepared me for my current roles and duties. But right after university, I decided to leave the lonely life behind. In the next 20 years, I sold margarine, chocolate, and lots of gasoline. The moment I met Tim and his terrific team of Hyperloop designers, I came to the conclusion that maybe I missed my destiny. What a spirit and enthusiasm, driven by the ambition to make a mark. I'm truly impressed and inspired. What if in my days I would have encountered such an endeavor that is both entrepreneurial and high-tech? Would it have motivated me to put my studies first and pursue a technical career? It might be. The Hyperloop is an advanced and yet simple concept that will revolutionize the way we look at transportation. Its inherent energy efficiency makes it possible to power it entirely by solar and wind energy. In Paris, humanity decided to stop the use of fossil fuels by 2050. That is fantastic, even more to world peace than to the environment, but it's not enough. We need technologies like the Hyperloop to be freed of fossil fuels by 2035. Our progress can be accelerated if we use this technology to remove freight containers from our roads. This will take away the majority of our traffic congestions as well. I'm looking forward to the inevitable success of this fantastic Delft Hyperloop team and hope to find ways to extend that to freight solutions for the Netherlands. The success of our team will not be a miracle, but it will be beautiful and magical. Please join me in a great round of applause for this team that for sure will put our country forward as an innovative frontrunner.
Well, thank you, Martin. To be honest, I have to say that it also requires hard work to manage it. And then I think it's now time for the moment we've all been waiting for. Our Delft Hyperloop design. And we all showed you this conceptual design. And it's now time for our detailed design. To be honest, it has changed a bit, but therefore it even makes me more proud to show you our detailed design. Enjoy. Ja, zeker. Wat heb jij voor?
Man, what a beautiful vehicle it has become. My name is Mars Scheuze. I'm the technical manager of Delft Hyperloop, and it is my honor to present to you today the technological marvel we have designed in just up more than 4 months. Now, I would love to tell you every single detail of our design, but as I understand, you all want to go home before midnight, so I'll keep it a little bit shorter. There's a lot of challenges when designing an ultra-high-speed vehicle inside a vacuum tube, and I would like to focus on 3 interesting problems, the 3 most interesting problems and the unique solutions we have found to them. The 3 things we will focus on is, first, we're going to look at how can we create a comfortable and ergonomic space for the passengers. Secondly, we will discuss how we can minimize the tube and track costs by using a magnetic levitation system. And finally, we will look at the most important emergency system, which is the emergency brake. But first, onto our passengers. We don't only want our passengers to have a very fast, efficient, and cheap form of transportation, but we want them to have the Hyperloop experience. And the Hyperloop experience would look something like this. Passengers are seated inside a luxurious chair in a spacious environment. They have their own infotainment system, their own lighting and audio. But the astute observer might be wondering, why does it have windows? Because if you can imagine, watching the inside of a tube for 30 minutes isn't really the most interesting Hyperloop experience you can imagine. But these are normal windows. These windows constantly project it's a virtual window. The screens are embedded inside the shell, and they constantly give you the impression of a landscape passing by to give the passengers the crucial sense of space. Now, in a confined compartment, that's very important, and this confined department would be quite easy to make if it wasn't that there is not a vacuum inside the vehicle as well. You see, sadly, we humans need oxygen to breathe. So that means that the whole vehicle needs to be filled with air. So there's a high pressure difference between the air inside the vehicle and outside of the vehicle, which means that you have a very high pressure force on your skin, on your pressure vessel. The reason that this vehicle has a nice round shell on the outside is because this is the most efficient shape to handle the loads of a pressure. Now, if we would strip away the interior of this design, you will see that this is what a pressure vessel looks like on the inside. Now, pressure vessels don't really like to have big holes in them. Preferably, it would be small holes quite far away from each other. That's why the doors is not one huge door, but the doors are on both sides of the vehicle in a zigzag pattern. Now, because these are such weak spots in the pressure vessel, there are stiffeners around those doors to make it extra stiff and strong around there. Now, we have already tested our production method for making this, and as you can see, this is what it would look like. The skin on the outside for containing the pressure, stiffeners in there for making it strong and stiff in the weak spots, and if I would try to, there's no way I could bend or break this. It's a super light material. It's so light that only the vehicle chassis is 3 times as light as the mass of the passengers with their luggage. Can you imagine an airplane being 3 times as light as its passengers and its luggage? The reason we make things so light is that you can imagine every kilogram you don't have to take with you, you don't have to accelerate it. If you don't have to accelerate it, you don't have to expend that energy. Also, the motors inside your vehicle, inside your track to accelerate your vehicle can be smaller. And finally, because your vehicle is lighter, the whole structure and the tube can be lighter and cheaper. So this is a cascade of lower cost by just creating something that is very lightweight. Another way to make sure that everything becomes very cheap is to make sure that you can make a cheap track. And we can do this by using another suspension system. Now, one of the first inventions of humankind was the wheel. And while it has served us very well for a long time, we have finally come to the place in time where we can no longer, we're going so fast now on the ground that it's no longer viable to use wheels. Like Tim said, you have trains and airplanes, and trains are just not going that fast. We need something with something new. And the way we're going to do this is using a magnetic suspension. And it's, magnets, they sound complicated, but it's actually really simple. All you need is magnets inside your suspension. You need an aluminum sheet on the bottom. And when you move a magnet over aluminum, the aluminum itself will generate a repulsive magnetic field, automatically letting the vehicle float. Now, the beauty of this system is that you can float at up to 10 centimeters, meaning that your track can have very low tolerances. It's completely passive, so I don't have to constantly power my system, making it very efficient. I don't have to constantly control the system, making it very safe. This is a zoom in of the suspension system. There's a few parts in there I would like to highlight. On the bottom, there's the magnets. But like I said, the vehicle needs to move to actually start floating. So there's also some wheels, but they only have to carry the vehicle weight for the first, say, 30 kilometers per hour. Now, because we can float at 10 centimeters, we allow the track to have a low tolerance to make it cheaper. but that does mean that the magnet will follow the track. So you still need to damp those vibrations so that the passengers will vibrate out of their chairs. So there's still a spring damper system in there, but it's passive, so that still makes it safe. And of course, we don't only have to levitate the vehicle, we also have to be able to center the center of the tube, and have to be able to follow corners. So there's a center beam also inside the tube. Now let's rotate the vehicle and take a look at some details in the bottom. The assembly you see right here, we call it our guns. And if I rotate it, you might understand why. You know, we figured, well, we're going to Texas, you know, land of the free, home of the gun. We might as well come in style and merge into their culture a little bit. But of course, this is not the actual function of the guns. In the middle, you see the center beam of the tube, and we also have magnets on these guns, and they make sure that the vehicle is always centered around this center line. But we integrated more parts into this system. Tim already said that you only need a linear motor at the start of your track and at the end of the track. You don't need any linear motors in the middle, but that does mean that you cannot brake in the middle either. But there can always something can go wrong, so you need an extra set of brakes on your vehicle itself. For that, we have come up with something which is always fail-safe, and it will automatically brake if something goes wrong. This is how it works. We have a set of motors on the top. You see springs right here. These springs constantly push on the magnets. So with these motors, we're constantly pulling the magnets into the springs. Now, if something would go wrong, if a motor would fail, if we would have an electricity failure, automatically, these springs would push the brakes into this position. And the nice thing about these magnets is that if they're pretty far away from the track, they only provide stabilizing forces. But if you put them very close, suddenly they generate a lot of braking force. So in a case of failure, the vehicle will always automatically brake. So what I've shown you is that even for a vehicle that moves at a super high velocity, it's still possible to have a very elegant design, to have a track that is very cheap, simple aluminum sheet, and that it's possible to make it all feel safe. Passive levitation, no need to control anything, brakes which automatically actuate. I'm very convinced that with this design of Delft Hyperloop, that we can revolutionize transportation with the speed of sound. Thank you.
Hey, but Mars, are you sure this all works?
Come on. Of course it works. We even already built a test setup. Now you might be wondering, wow, that doesn't look like a Hyperloop vehicle at all. No, that's true. We figured that it was pretty difficult to make a test setup where you can measure all the forces on the magnet while the magnet is moving super fast, not to mention the long track you need. So instead we decided to have a track, or have a magnet right there, and have a track which rotates with respect to the magnet. And the forces we have calculated are exactly the forces which come out of this test setup, so that's already good. And the next step, we already have a design for testing the whole vehicle on a test setup. So even before we even can we're going to California, even before we put it in the tube, we can already test all the dynamics of the vehicle on this test setup, where the track is simulated by a lot of moving wheels underneath the vehicle. But to prove it now, here and now, we also have a little demo for you to show that this levitation mechanism really works. And for this, I am going to need my lovely assistant, the chief powertrain. he, he, he knows a lot about magnets, and he convinced me that this should work. All right, let's turn on this camera here so we can.
Yeah, for a close-up.
Oh, sorry,
Let's
short
see if
time.
this works.
So similar to the
Of course.
test track that I just showed on the slides, we are now going to simulate the Hyperloop vehicle. Can you show the Hyperloop vehicle? Yeah, see, it's, oh, careful, yeah, there's a magnet on there, you know. All right, yeah, there's a magnet underneath it. Put it down for a second so you can show that it's, see, there's no magic, there's no motors in there, right, Tim? All right, so we're going to simulate a track right now by rotating this aluminum disc. The disc is rotating much faster than Tim, of course. There's a gearbox inside there. We're still accelerating. So usually the linear motors would be doing this for us. What do you think, Tim?
Do you think we already have enough speed?
I think we should be able to float right now. All right, Kian, show us. There it is. Can you keep it under the thumb, Kian? Is it a... Perfect.
Dankjewel. All right. So luckily, this does work. The showtime. It's already been. So now we can take a look into the future of our project. And that's quite nice, because already coming Wednesday, we will leave with a part of the team from Amsterdam till Texas to present there our Hyperloop design at the Texas A&M University. We are there to convince the judges from Tesla Motors and SpaceX that our Hyperloop design is the best Hyperloop design for the future. And then we get back to the dream hall, start producing our Hyperloop vehicle, start assembling it, and start testing it, all before we will go to Rocket Road number 1. That's in California. That's the headquarters of SpaceX, the place where SpaceX built the test tube and where we can compete to the other teams of the Hyperloop competition. So what have we seen now? We have seen that a guy is cycling through the wind, and it costs him a lot of energy, but not only this guy. All the current transportation systems are using a lot of energy by propelling themselves through the wind. We have seen that the Hyperloop is the best solution for this problem. And we have seen that with our unique design of our levitation mechanism and safety mechanism, we have a really safe, fast, and affordable Hyperloop vehicle. Thank you. Do you all remember this? Going from Amsterdam to Enschede in 2016? Well, if you take a look in the future and the Hyperloop becomes reality, how much time would it be in 2015? It will be possible in only 14 minutes. And that's what I call revolution. Thank you. So, then now it's time for some questions. And here, we have a talk box. There's a microphone inside. So is there anyone who has a question? I see one over there.
Okay, thank you. Why is it that in all the artist impressions, when the trains pass, they make a nice hissing sound? There's a vacuum in the tube, so the trains will be silent. And therefore, in your design, it has a lovely aerodynamic shape. It has the shape of a raindrop. Why? It's in a vacuum.
Yeah, it's a very good question.
I know.
Is my one on?
Can we put
Yeah,
the
of course it's a
microphone
good
on
question.
Marco?
We always call it a vacuum. In physics, we have different types of vacuums: hard vacuums, soft vacuums. The ones we are in is a soft one. This means that there's still some air inside the tube. There's about 1,000th of the air of which is usually in your environment. The reason we don't go any lower is that if you would go a lot lower, then any single leak anywhere in the system would completely put the system down. Now, it's quite simple still with normal pumps to get down to 110, 1 pascals. So we are staying at somewhere around 100 pascals, so that if there's a leak, you can keep it at that pressure. This does mean, however, that there will be still some air inside, and that you do have to take into account the aerodynamics. A very important fraction is the size of the vehicle with respect to the tube. And there's an optimum somewhere where if you make the vehicle, if you make the tube any smaller, there will be so much air you will be pushing in front of you that the electricity will become high again. The drag will become high again. And if you make the tube bigger, that's the costs of the tube will become higher again. So there's an optimum somewhere, and we try to keep this ratio, to keep the drag and the costs of the tube at an optimum level.
Okay, thank you. Nice answer.
All right. So does anybody else has a question? We have another talk box.
Yeah, thanks so much for the presentation. Very cool. I was wondering, and I was discussing how do you make sure you get a vacuum that big? I'm here.
Ah, there, sorry. I also lost the question. I was just looking for you.
Yeah, so you need you not only need a very well vacuum with not much air in there, but it's also a very long tunnel, right? If you're talking about distance from, let's say, Amsterdam to Nice.
Yeah.
How do you make that work?
Well, how we're going to get the whole tube on a vacuum? Well, surely we're not going to use one pump at one station. The best way to do this, we think, is to place a vacuum in every pylon. So the vehicle is, the tube is suspended by pylons. And if you put one at every pylon, everywhere you have electricity, you can, the costs of the vacuum pumps is not in the same order of magnitude as the costs of all the pylons, the whole structure. And also pumping down the tube, if you have that many pumps, is in a reasonable time. It's like in a few minutes. So it's a reasonable problem. It's not the thing that's probably going to block the Hyperloop for reality.
Okay, thanks. And if I may, I have another question, more about safety. Mm-hmm. You're talking about you need a brake system, which I think I agree with. And now one reason there's not one in an aircraft is because if you would brake, well, first of all, you would plummet down. The second reason is you cannot get out. How would you get out if you need the brake here? Yeah,
also a very important thing of this concept is that, exactly, you get stranded somewhere, how do you get out? If you remember from the picture I showed where we zoomed into the bogie, the suspension, where the magnets were on the bottom and there were 2 wheels on the sides. Every wheel, so there's four wheels on each, there's 4 wheels which are motorized on the vehicle as well. They have a motor. So, you're not going to go very fast. You're going to go fast enough to get to the nearest emergency exit within a reasonable amount of time.
Okay, thanks so much, and good luck next week.
Thank you.
Yeah. My question was, how many people can you fit inside one of those capsules, and where do they put their luggage?
Yeah, the people inside the vehicle. There's really no limit to how long you would make your vehicle. Okay. The reason we chose to put 8 people in there is that we're just making a prototype. We could make it 20 meters, but it would be very difficult to get it to the United States. So you would never make a vehicle, a Hyperloop vehicle, with say 2 people. That would be too inefficient. You would have too much structure with respect to your amount of people. You also probably wouldn't make a vehicle with like 200 people in there, because why not just let multiple vehicles go through the tube? So you would want to be somewhere in the middle. We decided with 8, but you could put like 20, 30, 40 people in there. Now we actually kept some space for the luggage. No one wants to be in the tail, right? No one would like to be in this confined space somewhere. So what we did is, quite a bit before the tail actually starts, the vehicle has a compartment where you have the lockers where you would put in your stuff just before entering the vehicle. So that's where you would put your luggage then.
Thanks.
All right.
Shall we do one more, Tim?
One more question is okay. I see one in front. Oh. He's very keen on asking a question.
You were saying that sadly humans need oxygen.
Yeah.
How do you make sure that there's enough oxygen in the pod?
In principle, you can take enough oxygen with you. Also, in the luggage compartment we have, there's enough room for taking with you multiple oxygen tanks. Also, if you remember the picture where you saw the passengers inside a cabin with this the circular shell around it, there's still some room on the top and the bottom, for all these safety systems like oxygen masks, stuff like that coming out. Also, if there would actually be a breach somewhere, a breach in your vehicle, something going wrong, of course, you can quickly repressurize the tube after setting in your emergency braking. So that no one would ever be stuck in the tube with no air, right? That's the most important thing.
Yeah, that's reassuring. Thank you.
All right. I think that was the last question, and I think it was a good question to end with.
Yeah, absolutely.
So then, there's still one thing left. I think we are still missing something,
Ooh,
right?
yes, I think so too.
I think around 31 things. And what I'm mentioning is our team. I already mentioned, to build an A product, you need an A team. And therefore, I would like to have our whole team on the stage. And I would love to introduce to you our Delft Hyperloop team.
Ja, die hadden we dan niet.
Ja, een beetje... Iets denser, een beetje naar beneden.
Gaan wij zakken?
Ja, wij gaan er ook voor.
Ja, daar kijk je. Oh. Nou, vooruit. Ga liggen. Ja, inderdaad. We moeten wel even wachten.
The Delft Hyperloop team, guys. Thank you. Oh no, wait. No, stay here. And what I already told you, we do not do this alone. We have a whole bunch of partners supporting us with this project. So ladies and gentlemen, our partners again.
Before we are leaving this auditorium to celebrate this fact with a drink, I would like to say a few words on behalf of the university. Delft Dream Realization of Extremely Advanced Machines, or Daydream. That's the given name to student teams who are realizing their technical dreams in one of the most exciting places on our campus, the Dream Hall, a playground where students can work 24/7 on their projects. The foundation for that is established in 1999. There was no hall, there was no office, there was no support, there was nothing. The teams that started back at that time, Dut and Nuna, had to overcome many obstacles to get to the point of actually building a car. But they have succeeded. After some more time, people realized the value of the dream teams for the university. And as a result, we now have this special place called the Dream Hall. Every year, a few hundred students are working there in several teams and designing, building and testing the most amazing machines. All teams in the Dream Hall are founded by the students. They take the initiative, they are the problem owner, and Delft Hyperloop is one of those teams. A team that's working on an ambition project that maybe change the way we will travel in future. My name is Frans van der Meijden, and as manager and coordinator of the Dream Hall, I'm proud of these teams. And not only me, our entire university is proud on them. Not only they generate positive exposure for our university, the participating teams became better engineers. This all was not possible without the financial and moral support of sponsors, family and friends. So on behalf of the team members of Delft Hyperloop and the entire university, a big applause for yourself. Beide. One more thing. If you're interested in the history of the dream teams, then I recommend you the book Van Dagdroom naar Daydream, which is available in the TU shop at the ground floor of this building. This is the way it looks. All right? Okay. I think it's time for a drink. So this will be the end of the official part of this evening, and I will invite you to celebrate this first milestone for the Delft Hyperloop with a drink that will be served at the Fide in the Auditorium. So I think follow the leader and let's take a drink. Thank you.